Going, everybody. So hello and welcome to today's webinar, The Waste-Free Mind, the last of our ESG Showcase series. My name's Sam Sakasiris and I'm the Membership Manager for Austmine in WA, and I'm your host today. Before we begin, and on behalf of Austmine and all of our today's presenting companies, I'd like to acknowledge that I'm hosting this webinar from the lands of the Whadjuk Noongar people. We acknowledge the traditional custodians of the various lands on which we all meet today and recognise the Aboriginal and Torres Strait Islander people attending this webinar. The ESG Showcase webinar series is meant to provide our members a way to showcase their solutions while sharing valuable insights to help overcome key ESG challenges. The ESG webinar series covers various topics and highlights the innovative solutions and technologies the MET sector is contributing to mining's sustainable future. Today we conclude the series with the waste-free mine. This webinar will feature Austmine members who will showcase their latest technology and innovative solutions around expertise in waste to energy technologies, sustainable waste management practices, waste reduction strategies, resource recovery and reuse, circular economy models for mining, waste disposal and remediation. We have 5 industry-leading member companies sharing their technology today and innovative success stories. Joining us to share their expertise are the following: Richard Stewart, the CEO of RemBind, Dominic Parsonson, Head of Sales for Titomic, Ben Kirkwood, Sustainability Strategy Senior Manager for Accenture, Nanne Vegter, Process Consultant for Core IPEX, and Jim Allenby, Managing Director for Parvate ESG. The format for today will include a short presentation by each of our presenters, and then there will be a Q&A at the end. If you have a question for any of the presenters throughout the webinar, please type them into the Q&A box at the bottom of your screen. If your question is directed to a specific presenter, please note their name in your question. This webinar is being recorded and will be shared with all attendees. So that concludes the welcome introductions. So without further ado, I'd like to welcome our first presenter, Richard Stewart from RemBind.
Thanks, Sam. Yeah, and thanks to Austmine for putting this on. I'm currently sitting in the UK, so it's an early morning for me, but I'll see if I can stay awake for my own presentation. I'm going to talk today about the treatment and reuse of PFAS contaminated soil at mine sites and how that aligns with the concept of a waste-free mine. So firstly, what is PFAS? It's a group of man-made chemicals that have toxicity characteristics. They're found in a range of products, including certain firefighting foams, non-stick cookware, and even, I found out recently, even in makeup and lipstick, which is a bit of a worry. Due to their highly stable chemistry, they're very persistent in the environment and they accumulate. They've been found in soil and water at an increasing number of sites worldwide, including commercial airports, defence airports, and also at mine sites now. So at a typical mine site, there are a number of sources of PFAS. The main source is from the historical use of certain firefighting foams for training, but also in the automated fire suppression systems throughout the mine. Once PFAS makes its way into the soil, it can then make its way to other parts of the mine. So, for example, if surface water runoff takes PFAS from a fire training area into a dam, and then water trucks load up from that dam and use that water for dust suppression on roadways, then you get a wider spread of that PFAS issue across the mine site, albeit at a more diffuse level. And so when you get PFAS in the soil is considered a waste, and then you have to look at how you're going to manage that. The treatment alternatives for PFAS in soil are shown here. The first one's landfill. Most of these mine sites that we're talking about are hundreds or thousands of kilometres from the local engineered landfill. So that's a cost prohibitive pathway, but also it's unsustainable to put large volumes of relatively low PFAS soil into landfill. The other options shown here are thermal treatment, which there's not really portable equipment available for that yet, for on-site treatment, and also it's energy intensive, so expensive. Soil washing, where you wash the PFAS out of the soil, is a viable technology. There's some portable equipment available, but then you're left with a PFAS liquid concentrate, which you have to deal with, which is costly and also logistically difficult. And the third option here is stabilization, which I'm going to talk about today. This is where you add a powder to the soil. It binds up the PFAS. It doesn't remove it, but it stops it leaching into groundwater, where it can cause issues with human health and the environment. And so the study that I've referenced here shows that stabilization is the most mature and viable of those treatment technologies for soil. And it's also the most cost effective. Another benefit of stabilization is it's the greenhouse gas emissions footprint. So this data, which is out of a US market report, which will be published soon, shows that stabilization has a 43% lower footprint than dig and dump or landfill, and 90% lower than offsite incineration. And there's also a much lower risk of injury and fatality because you're not having to transport that soil offsite outside the mine. So I'm going to now run quickly through a case study that we did earlier this year with Rio Tinto. During a facilities upgrade at one of their Pilbara mine sites, they found some diffuse PFAS contamination around a truck washdown bay. The options for disposal to landfill weren't available. There's a very remote mine site, and the client decided to assess the feasibility of stabilising that soil with our RemBind stabilisation products and reusing it on site. The rationale for using our products at the time was that they'd been applied at full scale in a number of large-scale projects worldwide, so they're fully proven. There was also demonstrated long-term stability data, which had been independently validated by other parties to show that once you bind this PFAS up, even though it's still there, that it won't leach in the longer term. It's also manufactured in WA in commercial quantities, so that was easily available, and it has several material handling advantages over some of the other powdered reagents that might be used for soil stabilization. So they sent us some soil samples from the site to do a feasibility trial at bench scale. This was really, the main aim of this was to determine the optimal dosage rate that could be used at full scale. Obviously, that's a cost-sensitive component to it, but they wanted to know what's the minimum dosage rate to achieve a reduction in leachability, which would allow reuse of the soil on site. And so we treated the soil with two different RemBind reagents at 1%, 2%, 5% dosage rates to get a dose curve, added some water during the mixing, waited 24 hours for it to fix, and then sent it to an external commercial laboratory for PFAS leachability analysis before and after treatment. And so this slide shows the results of that trial. 2 RemBind reagents, 3 soils that were provided by Rio Tinto, and the 1-5% additions. And in summary, a 1% dosage of RemBind 100 product reduced the PFAS leachability in that soil down to the level of reporting of lab, so basically non-detect. And that was, but based on the success of this, Rio Tinto decided to then take that into the field for full-scale treatment of the soil from around the wash bay. They treated about 3,000 tonnes of soil. They went to a 1.5% RemBind addition because just to take into account scale-up factors, it's a little bit like bucket chemistry in the field. They used an excavator and a sieve bucket to do the mixing into the soil, and a water truck to add water for dust suppression, but also to enhance the binding process. Rio Tinto then independently validated the treated soil and showed that the leachability had been reduced by more than 99%, which was consistent with what we'd shown at bench scale. They then approved that soil internally for on-site reuse, and they placed it in an area away from the main mining activities. And you can see the dozer compacting the soil there on the right. So the take-home messages from this presentation, really that stabilisation of soil and reuse at the mine site can be applied really cost-effectively and practically using equipment that you would normally find at any mine site. It has a relatively low greenhouse gas emissions footprint, which is important, becoming more and more important nowadays, compared to dig and dump and incineration options. And because we're turning what's essentially a waste soil into a resource that can be reused at site, this aligns really well with the concept of a waste-free mine. So, thank you.
Thanks very much, Richard. Obviously a very relevant issue we have right at this minute. Next up, I'd like to welcome Dominic Parsonson from Titomic.
Thanks very much, Sam. Thanks very much to everyone for the opportunity to present. One of the keys we believe at Titomic to sustainability or waste-free environments is the concept of repair and reuse. And if you're going to continually repair and reuse existing assets, it's also important that the technology used to do these repairs is sustainable and also low energy and low waste consuming. So this is what I'll be discussing today. So what Titomic does is we're an Australian company, and we have developed a capability to utilize novel sources of metal particles, and using supersonic particle deposition, we can thereby prevent corrosion, restore geometries, and keep existing infrastructure going longer and more cost effectively. The way the process works is that we take a metal particle, and unlike HVOF and many of the high energy applications, we never melt or heat the metal. So what we do is we take these metal particles and we accelerate them to supersonic speed utilizing a heated gas. And as these metal particles hit a substrate, they plastically deform and turn back into a solid metal. And all of this is done utilizing air as our accelerant gas and utilizing a low energy input, because all we're doing is we're heating the gas rather than melting the metal or utilizing any other fossil fuel derivatives to create the energy to melt or solidify the metal. As you can see by the image on the screen, we can either do it in a very complex robotic solution, or we do it in a mobile handheld solution. And all we're doing there, as you can see in the drawing, is we're taking a gas, putting into a heated chamber where we heat it up to 4, 5, 6, or 1,000 degrees C. As the gas is released out of the nozzle, a convergent divergent nozzle like a rocket nozzle, we inject metal particles into the stream, which accelerates those metal particles to supersonic speed. And as they hit the substrate, they deform and turn back into a solid metal. So where is this useful in the mining environment? And we have a number of case studies where we have demonstrated that this can be used to sustain mining equipment and keep it in service substantial for much, much longer. In this application, which is an approved repair process by Rolls-Royce or MTU, these diesel engines are repaired every 6,000 hours. Historically, they were using an epoxy resin to repair these large diesel engines. And epoxy resin itself is a fossil fuel derived raw material, and therefore doesn't meet those requirements for sustainability or waste-free environments. What we do is we use a portable or handheld system where we deposit metal directly onto the diesel engine crankcase or the diesel engine itself, and we're able to extend the lifespan to meet 4 refurb cycles and exceed 23,000 hours of repeatability or repeated reuse. So this is a low waste, low energy metal repair process that enables these diesel engines to stay in service substantially longer. We're able to do the same technology for repair of bearing housings, and other components on a mining surface or mining environment. Here we've used a nickel powder to repair a bearing housing and a sleeving to ensure that this system can be put back into use. Historically, this would have been repaired with a weld, and a weld is a high energy utilization technology, whereas, as I said, this uses a very, very low energy. In fact, many of our systems run off solar power or battery to ensure they can be used in a mobile environment and in a more sustainable way. One of the challenges we see when we're utilizing our technology out in the field is that when repairing things like radiators on large wind turbine environments or diesel tanks in this instance. It requires the drainage and removal of hazardous fuels or hazardous oils. In many cases, this results in wastage, spillage, and contamination of soil. In this particular instance, we have demonstrated we are able to repair both a oil transformer as well as a diesel fuel tank utilizing our technology without having to drain, and therefore without putting the environment at risk by contamination. It's a low temperature application. The temperature of the metal never exceeds about 30 or 40 degrees C. There's no flame involved. There's no molten metal involved. So very, very safe. And it creates a high density impermeable coating and replaces in many cases, again, as I said, welding or epoxy repair applications. One of our most recent success stories, and this is an application that's what we would call mining adjacent, and we'll be rolling this out across the rail infrastructure requirements throughout Australia, is where these very large electric motors often incur damage on the bearing surface, and typically these would then be stripped down, which requires huge amounts of labor and effort before they're repaired. With our process, we're able to take these very large motors, and without stripping them down and incurring large labor costs and wastage costs, we're able to very rapidly, cost effectively, and safely repair and restore the shafts, ensuring that they become suitable for reuse. So these we have now done over 12 motors, and we expect to do another 300 or 400 over the next 14 months in the Victoria region, and then we will look at extending that across Australia. So all in all, the purpose of this technology is to be able to rapidly and cost effectively ensure you can repair and sustain mining infrastructure. It does it in a low wastage environment. The only waste byproduct is metal powder, and that metal powder will be materials like copper, aluminium, nickel, or zinc. Low energy consumption. The only energy is required to heat the gas. We are not melting metal, and there are no nasty chemicals or nasty waste byproducts from the application. Exceptionally easy to use, and it has a number of benefits in that respect with regards to waste reduction. It has economic benefits. It enhances the skill levels of our operators by providing them extra skills and extra capabilities. It provides supply chain independence and also allows you to bring that repair methodology onto the mine site as well as remote, therefore meaning you are not shipping expensive and heavy equipment around the country to repair facilities, which in itself is not a particularly sustainable methodology. In fact, this easily mounts onto the back of a utility vehicle or a ute and can be run remotely to do any of these repairs that I have mentioned. So if you have any further questions, please feel free to reach out to our team and approach us via titomic.com. Thank you very much.
Thanks, Dominic. Great innovation and technology there in that waste-free mine space. Next up, we have Ben Kirkwood from Accenture.
Cheers, Sam, and g'day, everyone. Okay. Did you know that that mining produces more than 44 times the amount of waste produced by all Australian municipalities? Or how about the fact that the Australian circular economy is targeted to be worth $30 billion by 2030 and around $210 billion by 2050? These are just a couple of reasons why the waste-free mine is a critical component to achieving sustainable mining. And it gives you an idea of the potential that can be unlocked when done correctly. G'day everyone, I'm Ben Kirkwood and I'm part of Accenture's sustainability strategy. Today, I want you to take away 2 points. The first is that when done right, mining operations can be circular with materials being repurposed and recycled upon mine completion. The second is that even when a small change in behaviour, it can have a large collective positive outcome from a sustainability perspective. So how can we actually go about becoming a waste-free mine? I believe there's 3 key ways to do it. The first is the obvious, your consumption optimization of resources across operations. This is your stock standard power, water and consumables optimization, as well as your improved mine design, which targets your minimal material movement. I'm not really going to go into this today, as I think you've all got a fair idea of the best practices and other ways to target that form of waste reduction. However, if you do want to talk about it, please let me know either in this forum in the Q&A or feel free to have a chat with me after this. The second is the criticality for embedded circular design. This targets the reuse, repurposing and recycling of componentry such as steel, tyres and other building materials. Given the amount of material that goes into developing and operating a site over its life, material circularity can have massive implications. And thirdly, the impact of sustainable human behaviour cannot be understated. Now, you can take a can, which we all know is made out of aluminium and 100% recyclable, but if you just go and throw it in the general waste bin, it's still going to end up in waste, in landfill. Now, speaking specifically to circular design, technology plays a key role in the way assets are designed and constructed, enabling them to be repurposed and recycled. This is becoming quite incredibly pertinent. With changing regulations coming into effect in Australia, we're seeing the disposal of some wastes completely banned. A good example of that is tyres for 2025. A good example of where materials are being recycled is Rio's current alumina refinery being torn down and recycled. They expect to get about 142,000 tonnes of steel from that and 300,000 tonnes of concrete. Meanwhile, a great example of repurposing is there's a few dongers sitting in the middle of central Queensland at the moment, housing some FIFO workers that used to be the accommodation for athletes at the Sydney Olympics, and they're still in use today. So technology really enables circular design across the asset lifecycle, and you can utilise tech to gain visibility across a project and enables you the ability to perform assessments which lead you to gauge your project's both sustainability and circularity credentials. That helps you to ensure that your projects are in line with your overarching sustainability strategy. Now, moving into design tools are all very much digital these days, and you can use the likes of digital twins and BIMs, and they can assist you with identifying build methods and processes which can enable ready repurposing of the materials used in construction. And developing strategic supplier ecosystems with a heavy focus on circularity can utilise tech to readily share sourcing and logistics information. You can then use that to validate claims, but also plan your recycling pathways for componentry such as steel components. And then finally, into circular project management and execution. Tech is obviously critical for ESG compliance and monitoring. So long story short, how can we embed circularity in mines? Well, designing camps for repurposing, particularly for those for short mine lives, is obviously a pretty good start. If you want to know more about how we can help you utilise these tools, pardon me, for sustainability, again, let me know. I'm always happy to have a chat.
Some great points around those 3 key areas that can be targeted, being ops, design and human behaviour. Thank you. Our next presenter I'd like to welcome is Nanne Vegter from Core IPEX.
Good morning, everybody. It's early morning here in Pretoria, South Africa, where I am. Today, I'm going to tell you about the impact our technology is making on recovery of vanadium and its future applications. I'm Nanne Vegter. My technical background is in extractive metallurgy. I have 40 years of experience in the South African mining and metallurgical industry, and I joined the IPEX 2 years ago. And then I embarked on an amazing journey of discovery of the complicated chemistry of vanadium. and I hope to be amazed and intrigued further as I go along on this journey. The parties in this process are Core Resources, who is a specialist developer of processes and technology in clean, stable production of minerals and metals. They focus on critical minerals essential for the world's energy transition. It's a company that has a very illustrious history, and they've just celebrated two momentous occasions. Core itself is 20 years old, and the laboratories, which were established by Mount Isa Mines, were built 40 years ago. IPEX is a South African technology company with innovative hydrometallurgical technologies to recover metal values from low-grade sources such as dilute solution streams. In today's case study, I'll be discussing the technology that we use to recover vanadium. Core IPEX is a partnership that is aimed at commercializing this innovation further. On the photograph on the left-hand side shows Chris Frobler, who is the founder of IPEX, and on the right-hand side, Dylan Mulver, who is a senior process engineer with Core Resources, and they're standing in front of IPEX ion exchange plant that was used for process development work at Core Resources laboratories. On the left-hand side is a diagrammatic representation of the conceptual way in which our process works. The process itself uses ion exchange beads, which are contacted with effluent solution containing the metal ions of interest. The ions are adsorbed onto the resin and leaving a barren solution that exits the adsorption stage. Once the resin is saturated with the metal ion, it's taken out of that stream, and it then goes into a process where the ion is recovered from the resin by using an eluent or a solution that specifically displaces the metal ions, and then that produces a product stream with high concentration and purity of vanadium ions. In that same process, the resin is regenerated and it becomes suitable for reintroducing to the adsorption stage. Core IPEX has refined and optimized the engineering, peripheral, and also operational conditions that goes with this basic aspect, and has applied that in its process. So the process was commercialized in 2006. At the Wapatskloof site, where there is a calcined tailings dump of a discontinued vanadium primary producer. It ran a campaign of 5 years from 2006 to 2010, and over that period recovered 860 tons of contained vanadium pentoxide in a high purity solution, which was sold to primary vanadium refineries in the region. The environmental impact from this intervention was that seepage tenor from that tailings dam reduced from about 8 grams a litre to 0.2 grams a litre over that 5-year period. In addition, since that project was done, half the tailings material, which is high in iron, was reclaimed and exported for iron making feedstock. Our current operations, since then, the second operation was started in 2017 and a third one earlier this year. Both were retrofitted at sites of South African primary vanadium producers. In essence, they replicated refined versions of that initial concept as applied in the first commercial site. These plants were engineered in-house and also project managed and installed by in-house resources. The modular plants have a capacity of around 20 tons of vanadium pentoxide per month. The feedstock to these plants are pregnant feed solution from the calcine heap leach operation, and also dilute solutions from the vanadium refineries. The photographs on the right-hand side show the heap leach barge operation, and then also containerized column and piping arrangements. The second commercial operation had a very reliable track record with availabilities achieved of over 97% over the first 5-year tolling contract period. Other vital statistics include vanadium recoveries of in excess of 90%. The plant handled influent concentrations ranging from 0.6 to 1.1 gram per liter of vanadium. Effluent concentration of 0.05 to 0.09 grams per liter, and then product solutions ranging from 35 to 45 grams per liter of vanadium. Our future, we're very excited about the possibilities of this technology, and we are targeting the expansion of this application to retrofit other vanadium producers, and also the Australian projects on vanadiferous magnetite from Western Australia and shale deposits of Queensland. We're working on the enhancement of the technology to produce high purity vanadium products for redox flow and aerospace applications. And we also know that there's potential application of this technology to other critical metals, and development work has been undertaken in this regard. The photo on the right-hand side shows the beautiful blue vanadium solutions that we've generated as part of our process development work. For IPEX, our ion exchange technology offers proven financial and environmental benefits to recover and concentrate vanadium from dilute streams. It could be retrofitted to existing operations, and it could also be incorporated in metallurgical cleanup and greenfield studies. And it offers a very exciting process route to high purity vanadium and other metal products. Thank you.
Thanks very much, Nanne. A great example of the ion exchange technology process being used effectively. Let's now move on to our final presenter for this series. It's Jim Allenby from Parvate ESG.
Thanks, Sam. Thanks, everyone. An honour to be the last presenter on the last of the series. Thank you very much. Just to not take long today, I think coming from a different perspective and different point of view here, the others, and fascinating to listen to everyone else today from a technical point of view, and looking at ways in which we can reduce waste in mining, and you know, fantastic the way technology seems to be moving. I think from our point of view, being a ESG advisory, you know, just to get through that first page, all the disclaimers that we love to do. Just from our point of view, we don't, I guess, work as technically as many of the guests on today. Just going to come from a slightly different point of view in that we'll certainly work alongside a lot of providers into mining, a lot of the companies that have presented today who who are on the supply chains of mining, as well as a lot of explorers. And I think a couple of points just to make is explorers will be miners too one day, we hope, and they hope. So I think one thing we've really sort of drilled down on with a lot of the explorers we work with is just making sure they get their processes and systems in place early, so that as they do go through their feasibility studies, as they do go through the different phases of exploration into discovery and into mining, that one thing we're very proud to have helped a number of companies with now is have those processes in place so that from an environmental point of view in their ESG, they can really set themselves up for future success. And a way of doing that, and it was great to hear Ben mention it as well, the human behaviour side of reducing waste and certainly improving emissions, etc. That human element is so vitally important. Clearly, technology is going to be the way we do it, but the human element and the willingness to try different things and to really embrace this ESG sort of position we find ourselves in it was just great to hear Ben mention that earlier. And it's great sort of from our point of view, working alongside a number of partners, and if you can see the screen, a number of accounting, legal, insurance partners, just to get this educational phase that we're currently in at the moment out into the market to mining companies, explorers, and service providers into mining. So just really want to highlight that, it really does start from a human point of view and from a governance point of view to really want to do this better, because clearly, as the other panelists have said today, the sort of benefits are clearly there from an environmental point of view, but certainly from a financial point of view as well, if we can get this right. And it's great to see. Just, at Parvate, we've been around over 4 years now. I think we're quite a mature ESG company, if I can say that, only being 4 years old. And we tend to, as I say, specialise in educating boards, getting reports in place, looking at energy solutions, whether that's reducing energy usage or reducing waste as an end product. The ways of doing that, generally, one thing I would say is if you can't measure it, you can't improve it. So just looking at ways in which we can always measure a company's sort of performance from an energy point of view, and certainly more so recently from a waste point of view. And we're very proud to work alongside a number of partners who are in, whether it's filtration, whether it's a way of chemically sort of, tailings, etc. And they're all been very strong from an ESG point of view to make sure, yes, what they're providing to mining is a great ESG story and is very good for reducing waste and reducing energy, but just making sure that their own sort of performance is up to scratch as well. So that's been a really important part of our sort of journey from the supply chains into mining as well. Like most will know, and I'm going to use an analogy here, often linked to the emissions rather than just the waste reduction. So the standards have come in from an ESG point of view, from an accounting's point of view. So the good news is for all of us that we've got some robust standards that we can now report against. There's less guessing as to what the actual, standards are going to be that we do need to report against, which certainly makes it a lot easier to implement these procedures and these changes. We're seeing from 2024, so from as early as next year, we're all going to need to do better, essentially from an ESG point of view. And something we've noticed at Parvate the last 3 to 4 months is this really strong focus on supply chains. From an environmental point of view, we're getting judged. What's talked about the most is greenhouse gas emissions, net zero targets, reducing carbon emissions. Clearly, it's been very well documented, and I think it'd be hard to argue that that's something that we all need to look at. But clearly, a big part of this is also what happens with the waste, what happens after the ore's been mined or whatever the process is. It's not just about reducing the emissions in the actual process itself, but it's what happens afterwards. What do you do with the waste? So very important. We all continue to, educate ourselves and make sure that, down and upstream in our supply chains, we've got robust positions in place and using the appropriate technology that we've heard a lot about today. And just from a purely visual point of view, just looking at, have discussions every day, and I'm sure many here do as well, about the difference between scope 1, 2, and 3 emissions. And certainly something we talk to certainly our smaller suppliers about when they ask us, why Why do we need to start reporting on our energy usage, and why are we starting to collect our emissions? Why do people want to know what we do with our waste? Well, because their scope 1 emissions and their waste themselves is going to be collected into the larger company's scope 3 and various other reporting metrics that they're being asked to from either government legislation or the large pension and super funds that actually invest into their companies. So all of us, whether we're a small company or whether we're a big company, yeah, I guess it depends on the complexity of the reporting and the complexity of the activities we need to go with. But it's certainly important to understand no one's too small to start doing better in this field, because someone, up the supply chain is going to be asking for this information. So I guess just to use that emissions analogy from a waste point of view. And I guess lastly, just to summarize that, the supplier's scope 1 is the end user's scope 3. Question, potentially from anyone watching, is this the same in waste? I'd love to hear your point of view and discuss it. And I think just from a large company point of view, as well as from a technology point of view, is how can we help supply chains to gather information and to do better, to make sure the overall environmental performance of a company, of a mine, of a process, whatever it is, how can we, all of us as a collective, from supplier into end user, into those treating the waste or the tailings, how can we all make sure we're on the same page and we're reducing energy, reducing waste, looking at the most efficient ways to do it? So certainly it's about sharing information, it's about collaborating and making sure that information is easily accessible and also, simple to follow. I think, one of the criticisms could have been this has been a very complicated field. So I'm very keen that we can all simplify it and work together.
Thanks very much, Jim. Another great angle on supply chains, getting those right with process and also helping those explorers as well. That's the last of the presentations. So we will start now with some questions from the audience. And I'll just get through those now. For Nanne, have you looked at the possibility of using your technology for bauxite residues from alumina refineries? And have you tested the efficacy of your resins in bauxite residues?
Yes, no, we haven't. We are aware of those applications, but we haven't worked on those. We'd be interested to investigate that further. We've mainly focused on vanadium recovery from primary vanadium producer sources, and we've done piloting work on recovery of base metals.
Thank you. For Jim and Ben, what are the qualifications / experience level of your consultants in relation to ESG?
Yeah, great question. We get asked that. I'm sure Ben's the same. We get asked that many times a day. How do you qualify to be able to give us this advice? I think my first answer is usually, if you're looking for someone to help with ESG, it's a lot about case studies and track record. I think there isn't an ESG degree as such. There's obviously environmental scientists, there's governance experts, there's the accounting profession from a reporting point of view. But pulling that all together to be able to offer ESG advice, I think my best answer to that would be look at the case studies, look at the work that's been done previously by that organisation. Clearly, Ben's at a large company, we're a smaller company, but to find out what the company's previously done. So, it's case studies, it's experience. Personally, mine came from a strategy point of view, and we've surrounded ourselves with smarter people, which is always a good approach. But it's very much look at what someone's done previous, look at their previous work, make sure that it's not, not a consultancy that's just popped up and thought this is a good idea at the time. It's people with a good track record of producing good outcomes from a reporting point of view, educational point of view, and outcome point of view.
I think you've nailed it, Jim. You essentially look at the track record, but if you're surrounding yourself by smarter people than yourself, I think it is a pretty good start, particularly when they've got a good track record to back them up and support their ideas and strategy development as well. So that's certainly how we operate, and I'm sure it's exactly how Jim operates. It's the track record, I think, is the best place to look.
Thanks very much, gents. Richard, for you, how much water do you need to add to the process?
Not much. So normally if you are adding water for dust suppression, that's normally enough. You don't have to add any extra. It's really about getting the soil slightly damp, and that'll encourage the binding process. So yeah, it's not very water hungry.
Thank you. And just another one for you, Richard, while I've got you. Mine sites can contain a number of different contaminants apart from PFAS. Can stabilisation can also be used to treat these?
Yeah, we can tailor the products to treat some of the heavy metal contaminants as well, and also some of the other sort of organic nasties. So we can tailor a solution and make a bespoke product for those contaminants. Yeah.
Thank you. Nanne, just a couple more for you, please. How is the core IPEX technology differentiated from conventional fixed bed ion exchange?
The technology is highly optimized, semi-continuous flow sheet with, and we use fixed bed operation, good water balance, and low resin inventory compared to other fixed bed resin operations. So we've really put in a lot of development work on the concept and also the operational peripheral equipment that goes with it, which gives us this enhanced performance.
And just on the technology, how mature is it? How long has it been around? Well,
as I mentioned, the first commercial operation that we had up and running was since 2006. It didn't, that ran for a 5-year period, and we've had a second operation that's been running for just over 5 years, and then a third one. So in total, we've been in operation 12 years with this technology, and over that time, we've incrementally optimized and improved the operation from that. So it's something that we have working. It's making commercially viable in its application, and we can show people the plant. It's something that works.
That concludes the presentation. Thank you, everybody who's attended, and we look forward to hosting you again in the future. A big thank you to all our presenters for sharing their experience with us today. Thank you, everybody, and have a great day.